This is the third video in a series about exponential and logarithmic modeling. So this is a example of carbon dating, which I'm sure you've heard about before, but when you find a fossil, scientists can use radioactive carbon that's left over inside the fossil in order to determine how old the fossil is. And this is based on the fact that you have carbon-12 and you have carbon-14 in your body. And after you or the living thing dies, your carbon-12 doesn't change, but your carbon-14 decays. And so it talks about that here. It decays with a half-life of about 5,700 years. And therefore, scientists can use this formula to estimate how old a fossil is. And R is a ratio of that carbon-14 to carbon-12. So here's our question. Estimate the age of a newly discovered fossil in which the ratio of carbon-14 to carbon-12 is R equals 1 over 10 to the 13th. And then they gave us the equation up here, so let's solve. Okay, so our equation is R equals 1 over 10 to the 12th times e to the negative t divided by 8,223. And they told us that T is going to be the time in years and R is the ratio of carbon-14 to carbon-12. So we want to know how old is a fossil if R is equal to 1 over 10 to the 13th. So what we can do is we can just substitute in 1 over 10 to the 13th for R, and now that's going to be equal to 1 over 10 to the 12th times e to the negative t divided by 8,223. All right, so just like normal, e is a constant and t is the thing that we're trying to solve for. So we're going to start by unwrapping all the stuff that's around that t. So to start with, that means we got to divide by the 1 over 10 to the 12th, or if we multiply by 10 to the 12th, because like reciprocal that thing, multiply by 10 to the 12th, those cancel out. And on the left-hand side, using our exponent rules, where 12 minus 13 is negative 1, we would have 1 over 10 equals e to the negative t divided by 8,223. Then, because our exponent is the variable, in order to get the exponent out of the variable, we're going to use our inverse property. We're going to take the log of both sides. So we end up with the natural log of 1 over 10 equals negative t divided by 8,223. Remember, I didn't include that little step in between, which is like natural log of 1 over 10 equals natural log of e to the negative t 8,223. Because this says e to the what power, and this whole thing would equal 1, and this comes down and multiplies in front, and blah, 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 blah. You remember all that from previous lessons, of course. Okay, so now we're still trying to isolate t. So again, I'm going to multiply, in order to get rid of the 8,000, I'm going to multiply by 8,223 over 1, and I'm going to make it negative in this step so that it cancels out, so that it cancels out that negative. So I'm going to multiply over here by that as well, negative 8,223. So we get negative 8,223 times the natural log of 1 over 10 equals t. And then we put that into our calculator. And actually, let me show you that just so that you do it right. Although I'm sure you were going to do it right anyways. So it's negative 8,223 times, remember the little E button? I wonder if we just type E. It does. So we could just type E. Oh, we don't need it. Sorry. Natural log and 0.1 or 1 over 10. Hit enter, we get that. So we get 18,000, what was that, 900? Yeah, 18,934.157, which if we round to the closest thousand would be about 19,000 years old. Okay, for homework you have number 41, so why don't you go check it out?